So if you have a polynomial, let's say p of x equals qx to some degree n. N is a positive integer, okay? And then you have middle terms, and then your constant term is a p, okay? So this is a polynomial with leading coefficient q and degree n and constant term p. Okay, so every polynomial has a degree. Okay, that in this case n, let's say, is some number n. It has a leading coefficient, so we'll call it q, and it always has a constant term. The constant might be 0, and therefore it might not be written in the list of terms, but there is a constant term, and we'll call it p. Okay. If you have your constant term equal to 0, then you can factor out an x and apply and get a new constant term which is not equal to 0. You can factor out whatever power of x you need to. But to apply the rational zero test, you need a non-zero constant term. So if your p happens to be 0, then you would just factor out whatever power of x that you need to until you get the right remainder or factor with a constant term in it, okay? But I think all these examples are set up for you so that you always have a non-zero constant term, okay? And I feel like once we get to looking at examples, it'll make more sense of what I'm talking about. So the rational zero test, what it says is that the number of, if p of x has a rational zero, then it is in a list of rational numbers such that each 0 has as its numerator a factor of p and as its denominator a factor of q. That sounds strange, but when you see me do an example, it's really easy to figure out. Okay. So this is the rational zero test, and I'm going to go back to my example that I started with, and I'll show you how it works. Okay, so the example that we were looking at earlier was, I'm going to change colors here. Okay, so here we have our example. The degree is 3, right? Remember, the degree is the highest power on x. Our q is equal to the leading coefficient right here, which is a 1. And our p is equal to 2. So by the rational zero theorem, you would take all the factors of q, all the factors of p, including the positive and negative. So the factors of q are plus or minus 1. And so p over q, which is the fraction, the numerator has all the factors of 2. So plus or minus 1 is a factor of 2, and plus or minus 2 is a factor of 2. And then 1 has plus or minus 1. So you write it like this, and then you go through all the possibilities because we're looking for possible rational zeros. So you take 1 over 1 is 1, so that's plus or minus 1. And then 2 over 1 is plus or minus 2. So there are 4 possible rational zeros, and they're here in this list. Okay, so the possible, and that's the key word, possible, because you're trying to narrow down your search. Okay, and this is where the synthetic division comes in. Synthetic division is a way of dividing a polynomial by a factor of degree 1. It only works if your factor that you're dividing by is a degree 1. And when you're looking for zeros, that's exactly what you're doing. You're dividing by a factor. So if 1 is a 0, then x minus 1 is a factor of your function or your polynomial. If negative 1 is a 0, then x plus 1 is a factor. So let's go ahead and test these values for our function. Now, we already know the zeros, right? If we go back to our graph, remember we found the zeros to be negative 2 and 1. And you can see both of those are in our list, okay? But let's pretend that we didn't know that, okay? What you would do is you would just start systematically. You would go through your list and use synthetic division. Now you can see right there, my very first try, I'm going to come up with the right answer because I know that the zeros are negative 2 and 1. So that's sitting right there at the front of my list. But let's pretend I don't know that. So I'm going to proceed and I'm going to go through and check each one of these. Now, to check if it's a 0, you can just plug it into your function and then calculate it. And you'll know if I plug in 1 cubed is 1 minus 3 times 1, that's negative 2 plus 2 gives me 0. So therefore 1 is a 0. But a very quick way to do this check is to use synthetic division. And so for those of you who are zooming in and would like to get credit for attendance, you can go ahead and try those 2 problems and they're using synthetic division, but I'm going to show you how to do it right now. So we're going to divide our polynomial, which is f of x equals x cubed minus 3x plus 2